storage. This means all of the databases and tables that we can see in our account and that we can also just run queries on. So we just can, for example, run a select on a table and we get the data returned. This is, of course, very simple and what we know. But what happens now if someone by accident is dropping a database or a table? This can be super problematic. If we don't have a backup strategy in place, this data is gone forever. And even if we do have some backup strategy in place, this has to be, of course, maintained. We have to do this on a regular basis. And even if this recovery has to be done, this can be a super tedious work because we not only have to recover the data, but also all of the structures, all of the schemas, and maybe there's some kind of keys on our tables. We also need to recover all of this. And in Snowflake, luckily, we can do this just out of the box, both for tables that have been dropped and also if we have updated or truncated some data in our tables. And we can, as mentioned, do this by using time travel just out of the box. So like this, we can access historical data. This means data that has been deleted and objects that have been dropped. So we can, with time travel, do three things. The first one is we can, as mentioned, query from data in the past. So if we have updated some table or if we have deleted some data, we can still query this deleted data. For example, by using timestamps in the past or query IDs, and we'll see exactly how this works. Additionally, if we have dropped some objects, we can also restore them. This is true for tables, schemas, and even entire databases. And also, we can create clones of tables. We talk about them also in a bit, from a previous state. So again, from some point in time where this table or schema had a specific state. So we had some specific data in it and so on. So let's have now a closer look at how we can use this time travel. So we can, just as mentioned, query historical data just by running some SQL commands. So the first option is to use a timestamp. So we can say select from table, this is what we know, and then we can just add the keyword at, and now we add a timestamp. We add timestamp and afterwards we specify the timestamp from which we want to query. So if we want to have this 1 hour ago, we just use the timestamp from 1 hour ago. And of course, in just a bit in the next lecture, we also demonstrate this hands-on. Additionally, we also have the option to use an offset. The structure for this is also very simple. We use add, and instead of timestamp, we can just specify offset and then the time that we want to have this. So if we want to go 10 minutes back in the past, we just use minus 10 multiplied by 60. So this is just the number of seconds which we want to travel into the past. So to make it easier and more understandable, I'm just multiplying it with 60 to have this 10 as minutes. So this is just the offset in seconds. And lastly, we can also use the statement before, and then we can specify a query ID. So we just say statement, and then we can use a query ID. And this will help us to go before the state of this specified query with this query ID has been executed. So maybe by accident we made some mistake, so we can just fetch this query ID where we made the mistake, and we can recover it from before this state. And additionally, as we have mentioned, we can also undrop entire tables. This can be again done by just using a very simple command. We just use the command undrop the object that we want to recover, for example, a table, and then the name of the object. This will recover a dropped table if it is within the retention period. And in just a second, in the next lecture, we'll also talk about the retention period. So in short now, this is just the period until which this works, until the data is maintained. And we can not only do this for tables, but even for entire schemas and also for entire databases. This is very helpful if we by accident have dropped an object that we didn't want to drop. Like this, we can just recover these objects. Before we go now to the retention period and the hands-on demonstration, let's quickly also look at a few practical considerations. So if we want to undrop an object that already exists, so for example, we drop a table called customer and then we create a new table that's also called customer, then we cannot undrop this table called customer because currently it already exists. So a simple solution would be to just rename our current object. And then lastly, if we want to undrop objects, we need to also have ownership privileges. So this is something that needs to be in place. Now that we have this understood, we want to demonstrate this also hands-on. Travel feature in Snowflake. This is a very important feature which allows us basically to travel back in time. So this is part of the data protection lifecycle. This means that we can just, if we have some accidental deletions or some modifications that would usually maybe cause some data loss, but we can prevent it or restore data using this time travel feature. So basically, as we have said, we can travel back in time before some deletion or some modification has happened. And we will see in this lecture how this works. So basically, we have here 3 different methods, and we want to explore all of those 3 methods. And this will help us to understand this time travel feature. Afterwards, you of course have again the chance to practice this yourself. And then following this, we will see how we can now restore the data. Because here we will now just demonstrate how this feature essentially works without even restoring the data. So let's just walk through this step by step. We will see how this feature works. What are those 3 methods of time travel? For this, we will be setting up a test table in our FirstDB database. So I just execute the table setup. This is just now the setup. And for this, we will also create a file format object and also a stage. So I execute this. Here we have this stage. This is just a publicly available stage. So you can also follow along with me and set up the stage and load the data if you want. So here we will just check if this works. We can use the list command and see here is indeed this customer CSV file. And now in the next command, the copy command, we can just load this. So we load it into our table and we see this has worked. Very nice. We can have a look at the table, query from it and see that now all of this customer data is in this table available. And now let's assume we made some, unfortunate update. So we made some mistake and this would cause some data loss. So we want to now use then afterwards the time travel feature to recover this and fix this again. So let's assume we do some update that is, usually here we would probably, if we want to update just one person's name. So here there should be somewhere this person and we just want to set this name, maybe the first one. So we would say maybe something like where ID is equal to 1, something like this. Let's say we do it like this, or we would just by accident maybe also forget about this where clause, which would then result in that all of the names would be set to this new value. So we would essentially lose all of that data. So you can see now everyone has this name. So here we think, oh no, we have made this mistake. How can we recover this? So this can be done using time travel. So we have the first method, which is using an offset. So how time travel works is we just query the same table, but with something from the past. So method number 1 is using an offset. So we could say we want to travel back a specific number of seconds or a specific number of minutes, but just this offset here uses seconds. So if I want to travel back 1.5 minutes in the past, then I would just use minus. So we go back in time, of course. We cannot go in the future, unfortunately, as of now. And here this would be then 1.5 minutes. So we multiply it by 60 because it is given in seconds. And this is essentially how we do it. We just use this select command. And of course, for example, if I use, let's say 0.5, we want to see probably then this mistake has already happened. So we just run it and we can see, yeah, here, this was not enough time because 30 seconds ago, I have already made this mistake. So we still see the data like this. And also I want to make one note. The amount of time that we can travel back in time depends on the edition that we are using. So in our edition, which is the Enterprise edition, we can travel back up to 90 days in the past. With the Standard edition, you can travel back 1 day in the past. So this is something to be aware of. And now if I, for example, let's change it to 1.5 minutes, then we might be able, okay, it was still not enough. So let's use maybe, let's say 2 minutes. Let's see if this works now. So if I do it like this, I see now the data is recovered. So 2 minutes ago, we still haven't had this data like this. So we haven't had done the update. So it would still show us the original data because we traveled back before this change was made in time. So this is really nice. And now, of course, we could recover this. We could load it into another table and we see how we restore this in a best practice way in the next lecture. But before we do this, we want to have a look at the other method. So method number 2 is using a timestamp. So we could just use a timestamp to just travel back before a specific time. So maybe we know exactly when this change was made. So we can just use this timestamp to travel back before this time to just recover and see the state before this time or before this change was made by using this timestamp. So for this, what we will be doing is actually we will just set up the session to UTC time, so we are all on the same page. And then we will also just query the current timestamp so that we can use it. It will make it just a little bit more convenient for us, so we can just copy it. So for this reason, I will just use alter session. I set it to UTC, and of course, we should use here this semicolon, but we can also run it just one by one. So session, I set to UTC time zone, and then I run this command and I can see this is now the current time. So I will just copy this and paste it so we can do it like this. And then we can now use this in also this one in here. And actually we will do this, but we will first set up the table. So the table is created. Then we will again just copy the data from the stage. And now we will see that this is how the data looks like, original data as we know it. And of course, now we want to make this update. So this update would again, maybe here in this case, set all of the jobs to data scientists. So we would lose all of the jobs. Let's do this. And actually, let's get now this timestamp so that we can travel back to this moment now. So that we can still do it before the update has happened. So I will again just select it and then copy it. And this is what I will be using now. And now I make this update. And then we can travel back to this timestamp before we made this update. So let's use this timestamp now. And we just paste it in here. We have this string and we convert it into a real timestamp. And then we will select it. And how this works is instead of using add and then offset, and add and then offset, we are using now here before and then just the timestamp where we specify the timestamp. So here we will paste this one in here. I have already done this. And now it is giving us this fixed timestamp. So how the data looked like at this time. And it seems like here we have the future data. So what is the issue? I think we have done here, of course, this mistake with date add. So this was, of course, not correct. So yeah, maybe let's use here a 0. So yeah, of course, it is not the correct date. This was a little bit of a mistake, but here we can also fix it actually just directly in here. And then I will do it like this, and now it works. And here we don't need to rush because, of course, the offset is always changing and it's very dynamic, so this might not be the good solution in many cases. But here with this timestamp, we know the time, and like this, we can just do this fixed one. Of course, in many practical situations, we just want to go back. We know, like it was maybe 3 minutes ago, roughly, we can do it easily, but the timestamp is just a little bit more reliable in that sense because it uses this fixed timestamp. But of course, we need to know the timestamp. So in this case, I have seen that now the data is available, and we have again this job like this. And of course, if I just query the table as it is, we would see that the job is actually at the moment, of course, data scientist. But if we run it with this timestamp, with this time travel, we can see that the data here is still there in time travel. It is still available, and we can now still use that data. So that's very useful. And now finally, we also want to have a look at the last method, which is to query before a certain query ID. So therefore, we will also again prepare the table. We will set it up again from scratch, and then we alter it again. So let's assume in this case, we are just removing all of the emails. So that's not very nice. We can see, unfortunately, all of the emails are gone, but they are not, because we can recover them from time travel. So if we know a specific statement where we want to go back before this query, basically, we can also use this specific query ID. So here we use again before as with also the timestamp, but now we specify statement. So in this case, we just need to know the query ID. We can, for example, find this from the history, which is also accessible from here in the interface. We can see query history, and we can see this was actually, in our case, this update command where the mistake has happened. So we can see in this case that we have here this query ID. We can also select it, and in here we can just have a look at it. So we can see this is the one. And also what we can of course do is we can copy it either from here or also of course from here. We could also just from here copy it directly. So we can say that this should be pasted in here. And then if we now query it like this, we should see again all of the emails. So now they are there. So this is very nice. And with this, we have now demonstrated the 3 different methods of how we can use time travel. And in the next lecture, of course, we now want to also insert then the data from this. Now let's have a look at how we can restore data using the time travel methods. So here there are some pitfalls that we have to be careful about, because if we drop an existing table and then we recreate it, so basically this is what happens when we use the create or replace command, we have also the risk that we lose the data and we cannot use this time travel method anymore. Because actually, let's demonstrate this. So we will see how this works, what is the problem with this, and now what is also the good method of how we should do this. So what is here the best practice of restoring the data using the time travel method? So for this, we will be setting up a table first of all. So we use again this test table. Basically, this is just some customer table. And we want to, of course, fill it with some data using here this customer CSV file that we are going to copy into this table. Let's also have a look at this data to see what we are working with. Here we can see that this is essentially the data that we will be working with. And now let's have our use case set up. So in this use case, let's assume again we want to update this table. So let's assume again we, by accident, just don't limit this, we don't use a where clause, and maybe we update everything. So the entire table, so here Tyson will be now the last name of every customer. So every row will have here last name set to customer, set to Tyson. And let's assume now that we make a second mistake and we haven't noticed this first mistake. So we assume everything is fine. Now let's say we make this mistake with the job as well. And now let's run the table again. this select on this table. And now let's assume we notice only this mistake. And now let's assume we want to recover only this mistake because we are not yet aware of this mistake. And this can cause a big problem when we use especially this bad method, because then we lose the capability of traveling back to fix this mistake that happened even before. So why this is the case? Let's see why this is the case. So the bad method would be to just directly recover the data using a create or replace statement, and then here using the select from this time travel here. We of course could run this command. So we want to go back just before this update. So we can go to the history of just showing here the query history, and here we have this update. So this is the second one. Here's the first one. Let's assume we didn't notice that this was actually a mistake. So we only want to go back before the last update. So I can just hover over this actually. And then I can go here to copy query ID and I will paste it in here. So a good best practice is also to just test it. So we run the select, which we are doing here. And let's assume again, we don't notice that here is this mistake as well, but we see, okay, drop is here correct. So we want to, like this, now recreate this table, and we assume that this is fixing our problem. So therefore, let's run it. Now let's run the select. We see in our case, very nice, the drop is fixed. Now we assume, okay, not a problem. We have time travel. So we can just find not this first, so here was not the second, this is the second with the drop, but this first one. Here we find this is the query that has caused this mistake. I copy the query ID again, I paste it, and then I am a little bit shocked. So even if I run this select, I will see this is not working. So here the requested time is either beyond the allowed time travel period or before the object creation time. And here it is actually before the object creation time. We are not beyond the allowed time travel period. This is just a couple of minutes ago. So it is actually before the object creation time. And the reason for this is because the create or replace command is completely dropping the table. We also will learn in a bit how we can undrop a table, but this is not so easy when we have a same table with the same name, because then it is getting even more complicated. But we learn about this undrop command later on. So in this case, actually, we pretty much lose the ability to time travel, because this is a new table, and even though it has the same name, Snowflake is using here a hidden table ID. So this is uniquely identifying this table. And this is now a different hidden table ID. Even though it has the same name, it is for Snowflake with this different hidden table ID, a completely different table. And it is not related to the previous one. So it is not storing this time travel data for this new table, because it's a different table and therefore we cannot use this. So this is now a big problem, and it is pretty hard actually to fix it in this case. So therefore we should rather use this good method. So let's set up our setup again. We want to just copy it and then also copy the data, set up the table again, and then again also have this update here. So these two accidents, these two mistakes we make. And then we want to use the good method. So the good method is actually not dropping the table. So this is the key thing. We are not recreating the table so that we maintain this time travel ability. This is what we want to do. And how we do this basically is we create a backup table. So we have this intermediate table where we paste in the results, and then our original table, our productive table, will not be dropped, but we just truncate it. So like this, we maintain the ability to time travel, and we will just insert then the data from this intermediate test backup table. So let's assume also in this case, we make just this mistake. So this is just actually this update with the, here, we have to use this one. So this is the last one, the second one. So I will also copy this one. And here, if I quickly run it from a select, I will see that this is also here. Tyson is still not fixed, but the drop is already fixed. So this is the wrong query ID basically. And if I would just recreate or here use this backup table, and then I say I want to truncate now this test table, I still maintain here the full time travel capability. And now I just insert it. And now if I select, I will see this has now updated basically again, or recovered this drop column as we expect, but not this last name. But now with this table, we still have the time travel capability. So I can now still go back. I can still see, well, this is the one that actually I wanted to use. So I copy this one, and we can still completely use this time travel feature with this table. So I can say I want to run a select, and now this is really the correct one. So I go through this, basically 2 or 3 step process. I create the backup table. So that's not a productive table. It's just storing the intermediate results. And then I again truncate it. And then I insert now from the backup table into our productive table. So when I do this, I can see I can still use it. So here, this is how we should do it. And this is hopefully demonstrating that we should not recreate a table when we want to recover it, but we should just truncate it and rather use this test backup table as an intermediate step. And like this, we can maintain the time travel feature. All right. Hope this was helpful, and see you in the next lecture where we keep talking about the time travel method also to restore some data. And we have also seen that it can be a bit tricky when we are using this bad method where we are replacing a table because we have dropped this table. And of course, in general, when we are dropping a table, this can cause a lot of issues, or we maybe drop a schema or a database, and we can also use this time travel feature with a specific command, the so-called undrop command, which we learn about in this lecture, to restore also objects like a database or a table or a schema to recover this data. And this method will actually also help us with this bad method of restoring our data, which of course doesn't mean we should still use this bad method, but we can still find a solution to this. So therefore, in this lecture, let's have a look at the undrop command. So how this works. First of all, let's again set up our table in the same way that we have also done. And now let's assume we do something we should be really, really careful with, is to drop an object, in this case a table. So here we should be, of course, very careful with, because if we don't have a backup, this can be quite a problem. And in this case, it would be a big problem if this would be a productive table, but not so in Snowflake. In Snowflake, we can easily use the time travel feature without setting up any backups or doing anything about this. So we have now, of course, dropped this table. We can see we cannot find this object. It doesn't exist, but we can, with one simple command, just the undrop command, recover this table. So I just use undrop, the type of object I want to undrop, table, and then the name. So here I use this customer table, I run this command, and then this table is successfully restored. And now we should be able to again use the select command. And we will also see that this method will even work when we are replacing a table. So this is what we will discuss in a couple of seconds. But first of all, we want to also show that this also works with schemas. So if we drop this entire schema, let me do this, and I run this command, I see this schema doesn't exist. So here we see schema doesn't exist. We can also see it actually, of course, in here. This schema doesn't exist. And now we can also undrop the schema. So again, undrop, type of object we want to undrop. We want to recover the schema, so we mention the schema and then the name of the schema that we want to undrop or recover. So I execute it like this. I can even quickly refresh our objects, and I see public is there again, and now we should also be able to query. So is the table also there? Yes, also all of the objects that are contained in this schema that we have dropped, they are also recovered. So we still also have access to this table. And now also, worst case scenario, maybe we drop a database. So in this case, maybe we would be in lots of trouble, and we can do this without using lots of time in Snowflake, without setting anything up. Here we just use this undrop command So if I run it, this select, I would see here this database doesn't exist. But now after I use the undrop command, I see this database has been successfully restored. I can now again use all of the objects that are in this database. So this is really, really useful feature, and it is very, very easy to use. We don't need to be worried about this too much, set up a complicated process here, but we can just use this out of the box in a very, very fast and simple way, just using one command. This is the beauty of that. And now let's also, as I have mentioned, revisit this option that we have seen before, where we have just replaced a table. This is a little bit tricky because we will see in a second why this is the issue. So let's assume in this case, we will also do this update again that we have seen before. And now let's assume we use, let me use here this update again. So here we have this one. This was the wrong one. So I will just copy here this query ID, and then we can again run the query. So we can see this was actually the correct one. I used the first one, so I should have used this one actually. So let me copy this one instead. But now actually, yeah, we see we couldn't do it anymore. So we have done the mistake really ourselves. We have replaced it with something that we didn't want to do, but this is now still something that we can actually fix. So let's say we want to now recover this table, because now this is a new table. And here, if I now use this undrop command, because this table has been deleted actually, we can see that this doesn't work because it already exists. So this is the issue why we cannot recover this. But if I would rename this, so essentially now this customer table doesn't exist anymore, but I'm just having this rename to customers wrong, and still we have this previous table that was already deleted, the customer table that is now still dropped. Now hopefully we are able to recover it using the undrop table command, because now there shouldn't be any more table currently that is called customers. So I can now hopefully undrop this. So if I do this, I can see now it has been restored. So this works. And then I can also, again, select from this table. And with this table, I can now also use, again, this time travel feature. So here I could now use some of this query again. So I can go back to the history and I can say, maybe I wanted to use this one. So I wanted to go before Tyson or before the analyst. And let's use, in this case, again, maybe this one. So I can say in this case, if I select this query ID, I can also paste it. And now I should still be able to use this time travel feature with this table that we have just recovered. Now, of course, we should be careful with this, because if we have dropped multiple customer tables, it will always use the last one that we have dropped. So here we should still be a little bit careful, but like this, we can also undrop tables, and we just have to be careful that, and this can also help us with replaced tables that have been dropped and like this recreated. Hope it was helpful, and see you. Feature, let's talk about the so-called retention period. This is the time that we can travel back into the past in Snowflake, and this option of the retention period, so the amount of time we can travel back, depends on the edition that we are using. So if you are using the standard edition in Snowflake, you have the time travel capability for traveling up to 24 hours back in the past. So this applies to the standard edition. And starting from the enterprise edition, you have this time travel feature available for up to 90 days. So starting from the enterprise edition. However, this doesn't mean that we can always travel back for 90 days for all of the objects per default, but this is a property that we need to configure. So this is the so-called retention period. So as mentioned, this is basically a property of our objects, for example, for our tables, and this specifies in this object, so for example in this table, for how much time we can travel back into the past for this object. So here the default value is set to a value of 1, and if we want to extend it, we need to modify this property. So per default we have this only for 1 day back into the past, and if we have the enterprise edition or higher version, we can increase this value. And this makes sense because time travel feature, this can accumulate additional storage and therefore also cause additional costs. And don't worry, in the next lecture we also dive a little bit deeper and talk about the exact cost that is caused by time travel. So this is the retention period, a property of, for example, a table. And we now want to also, of course, jump into our Snowflake account and have a look at how this looks like in practice. So if I jump into my account, I first of all want to have a look at where can I find this property. So if I run the command show table like, then here I can use this wildcard and then see the customer table. So this is just basically all of the tables that contain something like customer in their name. And if I run this command like this, I can see no queries found. So let me try it like this, customer, something like this. And then we see there are no tables. And this is a bit surprising because we can actually see this customers table, that this exists. So the question is, first of all, why this table is not there. And in this case, it is because we have to make sure that we select the correct schema. So therefore, I should also, in this case, use our first DB. And here we can also use just the public schema. I think this is the one. So if we now rerun it, so in this case, we see only the one that is in the current schema that we have selected. So here we can see now this table, so the customer table, and we can see some additional information. So let me maybe close all of this. We don't really need to see also the history. So let me also close this. So here we can see this customers table and also this customers wrong that we have also previously created. And here you can see now this property, the retention time. This is exactly the property that we talked about that is related to the time travel feature. So this is true for our 3 methods with time travel, and also of course undrop. This is also a time travel feature. So this is also concerned with this time retention time here. So now let's modify this because we have a few ways of doing this. The first one is for an existing table when we want to just modify this property. So here we would just use the alter table command. This is the table that we want to alter, and here we set the property to a different property. So this means that we would here use a different value. For example, I set it to a value of 2, which I can do because I'm using the enterprise edition. I see statement executed successfully. And now if I rerun this command, I should now see also the value of 2, which means that we can now travel back in time for 2 days. So this is now how we could modify this. Another way of doing this would be to do this or specify this property when we create a table. Sometimes we also want to write in the beginning, want to just set this per default for a table. And in this case, we could also do this by just mentioning this property after the create table statement. So it is actually part of the statement, but just after we have specified the columns. So we close again the parentheses, and then we can specify and set this property. So for example, if I set it to a value of 3, this is now this retention example. And if I show tables like, then this table should appear here. And here we can see, of course, this one should have the default value of 1, and this one, the retention example, should have a value of 3. And this is indeed the case. And now we also want to make sure that we are not doing this by accident, setting this to 0, because sometimes this might be okay, and we talk about different types of table like temporary table or transient tables later on. But we should be aware that when we set this to a value of 0, so for example, we do it like this, and then let me maybe show this table again. So when this is set to a value of 0, we cannot use the time travel feature at all for this table, basically. This means we do not store anything in time travel, basically. So Snowflake is not storing anything in time travel. We can basically, for this table, not use it at all. Let me try to do this and demonstrate this. So if I would now drop this table, this would be pretty much lost. So at least with time travel, in the next section, actually, we talk about the fail-safe feature. But for this, we had to reach out to the Snowflake support. So in this case, with time travel alone, so from just by us users, we cannot easily recover this. Basically, we cannot recover this at all. So let me drop this table to demonstrate this. If I use this, so I drop this table, I say drop table, and then I want to execute this. And now this cannot be undropped. So if I try now to undrop this, so I try to undrop it, we are not able to do this. So let me execute it, and we see this table did not exist or was purged. So you can see that this is not available anymore. So we have to be, of course, aware that once this time travel period has passed, we cannot recover it using the time travel method. But for this, we could in some cases, and therefore we talk in the next section about fail-safe. But for this, we have to reach out to the Snowflake support. So for us as a user, we cannot access this anymore. And now, finally, we also want to talk a little bit about the cost that is incurred with this time travel feature. That we have the retention time as a property in our tables, and that we can define it, we can change it, and it is not set per default to 90 days, even though we are working with the Enterprise Edition and we would have this capability. So the question is, why would this be the case, and why wouldn't we always set this to 90 days? And the very simple answer is just cost. So we might not need it for all of the tables, and the more we have this set to 90 days, so the longer the period is, the more storage would be needed for time travel. And to understand the cost of time travel, we only need to understand that all of the costs arising from time travel is purely storage cost. Of course, also when we run commands, then we need our warehouse and so on, but the pure fact of using time travel only occurs the cost of storage. So this means that whenever something in the table is changed, only this incremental change will also be used as a storage. So we have this in a very efficient way, so that we only need to pay for the additional storage when something was changed. For example, I change a couple of values, let's say 10 values, then of course we need to still store those old 10 values, and we need to pay for this. So this is the actual cost of time travel. And now, of course, when we have a table that has huge amounts of changes, then this can also accumulate, and therefore we want to have a look at how we can monitor this. So therefore in this lecture, we will run over a few commands to see what we need to know about these metrics. So first of all, if I run this first command, I will see that here I, of course, have to use the account admin so that I'm sure that I have enough permissions to query this storage usage here. And in here I can see now the overview by date. And in this case, we can see the storage bytes in total, what is stage, failsafe, and hybrid table storage. And in this case, we don't see really this broken down. So here we only talk about the database. And in this case, we won't see the time travel. So what we want to see is breaking this down a bit more. And we can do this by having a look at the actual tables. So in this case, when I run this account usage table storage metrics table, then I will see that in this, I see it broken down by the tables. And then also when I go to the right side, I see active bytes. So this is now broken down into this data protection lifecycle. So we have the active bytes. This is what is currently in our data. And then we have also time travel, and then also failsafe. And failsafe, of course, we want to talk about in the next lecture. Essentially, this is once the time travel period ends, it goes into failsafe. But we talk about this in the next lecture. And here we can see in our case, yeah, we have a few tables actually, not too many, where we have something in time travel bytes. And very interestingly, even here, we see that there is more in time travel bytes than in the active bytes. So of course, if we drop an entire table and then maybe we drop it multiple times, then we also see that this can, cause more bytes in the time travel. And you can see also in here that we can even have multiple tables with a different table ID. So this is the actual identifier of the table that we talked about. So you can see that one table is not like another table, even if it was recreated. So here we can see this broken down, and of course we could make this a little bit more easy to understand by just using all of the columns that we're interested in, and we can also just structure this into gigabytes for the storage and time travel, just to have this in a little bit of a nicer overview. And in here we can then see all of the tables, and then what was the storage used in gigabytes, and then also for time travel. So in here you can see now this broken down in a nicer overview. So this is it about the cost of time travel, essentially just additional storage cost. And the storage cost is just the same cost also. So we always pay one price for the storage. And now that we have talked about time travel, let's now talk about the next component of the data protection lifecycle, which is failsafe. That's what we are